Hi, this is Don, and I want to finish up Darcy's two problems in the discussion on chi-square. And this one is a test of independence. And we're looking at data that gives us the political leanings of males and females. And we have the counts observed. And we want to know if there is any relationship between gender and political leaning. And to do that, we're going to run a test for independence because the null hypothesis is there is no relationship. So we will go to Stat, and we're going to tables this time because this is a contingency table. Get it down there. And we have summary data. So I am going to select using the control key, Republican column, Democrat column, independent column. And then the row labels are in an appropriately labeled row. We don't need to worry about the column label and the group by label. On the display, we do want to get the expected count. And we're going to use the chi-square test for independence this time. And we're not doing confidence intervals. Bring this up. Our confidence level is 95%, which gives us the alpha we want of 0.05. I hit compute. Let me bring this table up there in the center of the screen a little bit more. And you can see that the format for the contingency table results are a count in the upper row, and then in parentheses the expected count. And you can see here the expected counts for the men and the expected counts for the women, and they're different, as they should be, because we've got different n values, different population sizes for the two. But if they're independent, then they should be proportional. And what this test is doing is checking that. Okay, so we have in our output down at the bottom the results of the test. The test statistic for chi-square at 2 degrees of freedom was 16.02, which is the same as Darcy's. And we have a p-value of 0.0003, very small number, definitely less than our alpha of 0.05. Therefore, we reject the null hypothesis. Just as a reminder, I have another little video on this. If you need to actually calculate the critical value of chi-square, you can do that using the stat calculators. And we're going to go over here to chi-square. And we know the degrees of freedom, 2, and we're looking at a right-hand solution again. We need that value to be 0.05. That's our rejection zone. And we compute, and we see the critical value of chi-square to be 5.99. Anything greater than that, anything to the right of that is in the rejection zone, and we reject the test. And that's the same thing we got when we used the probability from the p-value from the previous test.